Thanks, everybody. My name is Marcelo. I work for IBM. And what I wanted to show you guys today is, okay, so what we're doing at IBM on a particular application that we have there, which is tied to the IBM Cloud, right? How we start adding process for doing logging management, and why we chose Elastic and how we did it, right? And give some examples on what we're actually implementing there for the ops team that is on the IBM Cloud side. I'm actually from development, so I work on a product that the IBM Cloud team uses in order to provide their service there, right? Okay, so just 1 second here. Originally, this was supposed to be a 1-hour talk, so I'm going to skip through some charts, and I wanted to spend more time doing an actual demo and everything, but I'll probably have to run through the first part and then kind of give an abbreviated example with some charts on the real-life examples, right, that I wanted to show more detail on. First thing is I wanted to say is a kind of an introduction for those who don't know what Openstack is. So Openstack is a collection of open projects, right? They started as a way for you to create and manage virtual machines, but they actually go beyond that today. They deploy these on the public cloud, private cloud, and the edge as well, right? And there was a foundation before that was behind the whole OpenStack project. It was called OpenStack Foundation. But now OpenStack is diverging to a few other projects, right? And they renamed the foundation last year. So it's called now OpenInfra Foundation. And they are looking into other projects like Kata containers and a few others. Their whole DevOps infrastructure was called Zoo. Is also part of this OpenInfra portfolio now, right? I put some the links there if you guys want to know more about all other projects that they're sponsoring, right? And then there's OpenStack, which is the original. There is a collection of several dozen of projects in there. Some are more mature, some are kind of at the bleeding edge, some kind of were created and died already, right? But yeah, you can have an overview there if you want to understand more about what the projects do and everything, right? But the important points is important points here are so if you want to have OpenStack installed on your environment, you're not going to use everything that they have, right? So you're going to use just the mature projects and what is stable right now. And in some cases, like in commercial distributions, you want to add to it, right? You want to add a few additional services on it. Some examples of commercial distributions. I put IBM and Red Hat separate because Red Hat was purchased by IBM, right? But they had an OpenStack distribution, a commercial one before. And IBM have actually multiple ones. There is still a couple of OpenStack distributions within IBM that are not the Red Hat distributions, right? And what I'm going to show today here as an example is one of those. So that's why I put it separate. Okay, so it's a nutshell just what OpenStack is for who don't have a kind of are not aware of the projects, right? Then like I said, there are multiple distributions of OpenStack in IBM. I am from the Power Systems organization. For those who don't know, who here knows what a power system is, first of all? Okay, well, I'm surprised. I actually thought would be less people. That's all right. So OpenStack is a project that I started since the beginning of OpenStack as well. And It was a more monolithic application. OpenStack kind of was modernized sooner. So it was something that the users would purchase from IBM. I would install it, and it would work out of the box in just one single node, right? There were you couldn't scale it well. So now it's more modernized. I'm going to show a little bit more. And that's why we need to do more log management and do more, starting to do, to go in this area of observability, right? Have more data that we look at, and we're managing thousands of nodes now, so it's really necessary for our ops team not to go crazy over time. And just for as an introduction on the OpenStack, I'm not going to spend a lot of time here, but basically the PowerVC is an OpenStack distribution that manages endpoints that are Power Systems endpoints, right? And a lot of our customers, they still want to use these Power Systems because they have a lot of applications that run into it. So legacy applications built on AIX, IBMI. So there are things that they are around for 20 years plus, and they're still going to be around for a lot longer, right? So as they start modernizing, they are migrating to the cloud. So that's the reason that we have this product to help them do that, right? And in Power, there are two, basically there are two architectures. There's one that we call PPC64. It's based on Big Indian. So Big Indian and Little Indian, I don't know if anybody knows the distinction, but Little Indian is actually something like the spin in physics, right? So you have a representation of data here, and suppose your memory is a continuum from top to bottom. So Little Indian, it's a left-hand spin. So the least significant byte goes first, and then the second and the third. So they go in progression, right? Big Indian is the opposite. So it's a high hand. So the least significant byte goes last. And so that's, with that, there are completely different setups on different hypervisors, different firmware, different everything, right? So usually these big Indian systems, they're what runs the AIX, the IBMI, and then the Linux, and etc. Although they can run as well as big Indian, they usually go in the newer systems that are Little Indian based, right? And there's a box in the middle. That's a hardware management console. The older systems, they need. So they don't have Nova stack running into it, right? So they don't have something that OpenStack can communicate directly through. So that's why there's a box in the middle there. So it actually manages all these legacy systems, right? And then OpenStack communicates to it. This is just to give an idea of the complexity, right? So now imagine these distributed across 12, 15 data centers, multiple regions in each data center, and thousands of systems on each of the regions, right? So it's a lot of stuff to manage. Oh, sorry. So that's the reason why we want to have a better visualization of what's going on. We're going to have multiple PowerVC clusters now, distributed across all these regions, and you want to see what's going on all these systems, right? This is just to give an idea of what is running on each of the controller nodes. So this is OpenStack. Most of you that already know OpenStack will recognize the system names here. So Keystone, Glance is for image management, Cinder is for storage, block storage management. Swift is object storage, and so on, right? So these are the basic OpenStack services. They're run into multiple controller nodes on each of the regions, right? And then you have some other services that are auxiliary. They are more for the cluster formation, and they also produce logs, and logs that are critical for us to visualize because they control things like failover. If something fails, one of the OpenStack service fails, you're going to see on the logs from some of these services here, right? Coral Sync and Pacemaker, for example, is the cluster formation services. It's like of something that you keep monitoring the services across all the nodes in the cluster, right? And you define resources, and if a resource goes down, it automates the failover on it. And there are some of the other that are known OpenStack services, Zookeeper, Memcached, RabbitMQ, it's for communication, right, across the services. So they're usual. In our OpenStack distribution, you're going to find most of these services there as well. And there are a few here that are not actually OpenStack, but they're PowerVC specific services. So there's a different user interface. It's a little bit better than the default one that OpenStack provides, Horizon, it's called, right? And they called it with the great name UI. So this is the service name. New UI, actually, it's the service name. Okay, and then each of these services are running on each of the nodes of your controller cluster, right? So you can have install PowerVC on a single node, but that doesn't scale well, right? Or you can add multiple nodes. If you want to have a Coral Sync and Pacemaker cluster, it's better if you choose odd number of nodes because they have there's a voting process. The nodes communicate to each other, right? And as you are adding more nodes, they might get into conflict, and there is what they call a tiebreaker process, right? So you want to try to avoid that and have odd number of nodes if possible. But for a 3-node cluster, basically, we did something very simple. We just ran the services on all the nodes. And some of these services, most of them are in the active mode. So they are active on all the 3 nodes. They're load balancing across all the 3 nodes, right? But there are a few, I think RabbitMQ or Zookeeper, 2 or 3 of these, they are active passive. So there is only one that is active. And then if there is a problem, it fails over, and it becomes active, the other one. Okay, so since all the services are running all the nodes, initially what we wanted to do is collect all the logs from all these services that are running in the controller nodes only. One other thing you could do is collect logs from these nodes here, the endpoint nodes, right? We're not doing that yet. So initially, we're just doing the collection of most of the services are in these controller nodes, right? As we expand later to collect from the other nodes, we're probably going to break the kind of the mapping on the clustering between the OpenStack services and the Elastic services. So we'll probably have a lesser number of Elastic servers to manage more of, I mean, you're not going to manage, suppose you have 100 endpoints, you're not going to install Elastic on all 100 endpoints. You just need to install FileBit, just the collection component, right? But you're probably going to need more than 3 nodes now because you're collecting logs for a bunch of additional nodes, right? So this is going to break the parity. But right now, it's something very simple. We're collecting logs just for the controller nodes, and Elastic is running all the controller nodes as well. And Elastic has its own way to implement AGA, so it's not using Coral Sync and Pacemaker. It has its own implementation of high availability, right? So it just need to, they have election as well. They have to point one Elastic node to all the other ones, and we can have different roles for data, or for master eligible roles, right? There is a page on Elastic that explains that in detail. But right now, it's something simple. Like I said, it's just 3 nodes, and they are all master eligible right now. They are all data nodes as well. So again, this is how the clustering is formed for Elastic, right? So we have the Elastic servers here. They are in a cluster. The Logstash and the bits, they are not in a cluster, so they just run locally. So if I have my controller 1 here, I collect the logs and I send them to the Logstash that is running in the same node. And then this node sends to Elastic, and Elastic is clustered, right? Kibana is not clustered, but I also have multiple instances running, because if one node goes down, I still want my clients to be able to access Kibana, right? So what did I do here? I just put them behind the AJ proxy with a virtual IP behind it. So if the node goes down, which is masking the virtual IP, so the failover makes the virtual IP point to another node, and then the client is still there on the same virtual IP address, right? Like very simple, like I said. So this is just so the requirements that we had. I guess this chart should probably have come before, but why we chose Elastic, right? So we wanted to manage millions of logs per day. It's a large quantity. So we wanted to do troubleshooting on the logs, some correlation, pattern identification, all things that Logstash and Kibana, Logstash, Elastic, and Kibana already support, right? Wanted also another requirement important. Once we identify a problem, or ops team, they want to be able to deep dive into the, reduce the time series to be within a few minutes before and after, to see what is affecting, what is causing those problems, right? And with Kibana, it's very easy to do that. Okay, so here are a few other best practices now for how to collect and transform best practices that we followed, right? So, like I showed in the other chart, there is several different services that we're managing there, right? And those services, they will change over time. So Openstack is a living distribution, so where they are always promoting new services or withdrawing services. For example, they have some metric components called Noshi. We already know that Noshi doesn't scale well, and we're using this right now, right? So it's very likely that Noshi will go kaput very soon. We wanted to make it easier when these stack changes happen to go and reconfigure things in production, right? So we what did you do? We made the configuration as granular as possible, right, on a per service basis. So if instead of defining one single file bit configuration for all the logs for OpenStack, we defined it one per service. So it's easier this way to automate later. So you, if you want to remove one of these services, just go to your, we use Ansible to do this automation, right? So you just go to your Ansible playbook and remove that configuration file from there. So it makes it easier to manage in the long run. So what else is important here? Oh, one other thing that OpenStack doesn't do well, it's log formatting. There are many different components, including those components that are called auxiliary, right? That are not OpenStack, are completely different, have completely different log formats. But even within OpenStack, if you go from one component to another, sometimes the way that they format things are a little different, although they are all, or most of them are supposed to follow a log format called OSLO. It's kind of standardized. But if you think about these services, they've been around for 10 plus years, more than that, right? Sometimes they they don't follow 100% the more modern definitions of the Oslo format. So things like exceptions, for example, if you go look at the exceptions, how they show in the logs, sometimes a service will, you put the first line of the exception, then they just do a new line and continue with the rest of the exception there. Sometimes the other services, they would have a specific preamble first. You have the process ID, the timestamp, and then the rest of the exceptions, they go over with many of these preambles, different logs lines, right, with preamble and the continuation of the exception. So you want to, long story short, I had to do a lot of trial and error in order to be able to properly format and properly recognize multi-line log entries, right? So there was a lot of work done in order to get that right. One other thing that is not particularly formatted is the log levels. Some services, they use error camel case, and others just uppercase. Others, yet they abbreviate some of these log levels. So you want to normalize this as well, right? So you want to have a normalized set of levels that you can filter out and show in a consistent way in your dashboards later. So that was some of the filtering we had to do as well. Well, clearly identify components, subcomponents, etc. Sometimes within different logs, you have components with a dash, something, a scheduler, dash API. On other components, they put underscores. So it was a mess. So you have to make sure that you normalize those things as well. Timestamps, sometimes they're different as well, right? Okay, so that said, all the difficulties, right? Okay, so before that, so there are some assumptions that you have to make when you do the indexing as well. So usually, at least in this application, what we usually want to do is index by time. You could have other applications that you might choose to index by something else, right? For example, by geography or whatever. But usually what you see out there, especially in the OpenStack implementations that integrate with Elasticsearch, because this is not the first, there are others, right? They usually assume indexing templates based on daily indexes, right? Which I guess a lot of applications that use Elastic today use that. So there's nothing new here. We do the same thing. That's the point here. This slide. Only one thing. We wanted to actually have our own index template suffix there. So we called it power VC, but it's configured on Ansible, right? So you could choose something else, but we called it power VC --*. So that's the index suffix that we chose here. But you probably want to keep this different from, for example, your system logs, the syslog stuff that you use. FileBit has other plugins that you can use. One of the ones that we use is the system plugin, right? So it basically runs the syslog, the outlog, and a few other logs that give you the information that is operating system related. So we want to keep this separate from the OpenStack logs. So other things that you need to be aware is as your cluster grows, in your case, at least 3-5 nodes is not a big deal, but as your cluster grows, you want to be aware of how you subdivide your data into shards and how many replicas you want to have in your cluster, right? In our case, for 3 nodes, we just have 1 replica each. So if one of the nodes go down, you still have a copy somewhere else, right? As you have more nodes, that becomes more important. There is a whole page on the Elastic documentation that explains a few best practices on how to choose these things as well, right? Okay, and then last thing is your dashboards. So once you have the data flowing and start showing up in the Discover tab in Elastic, so we start creating dashboards, and then you sit together somebody from the ops team, and they tell you, oh, my problem is this. How do I make it better, right? So then you both start creating a dashboard that might be an attempt on how to solve their biggest daily problems, right? And then you save it and iterate and create other dashboards. And that's what I try to capture here. So it's an interactive process, right? So you have this whole configuration that you do. So you do collection from all the OpenStack log formats. You have to properly parse them, make sure they have the same levels, the same time, the definition of the timestamp are the same, right? So you do all this normalization first, and then you, for example, in the OpenStack case, where you have most of the log entries, you have this preamble data with process ID, request ID. You have module ID, right? So you have a few things that most of the logs have. So you want to do this first before you start sitting with your ops guys and start creating dashboards. And the other thing you want to do is, besides this preamble, the logs have a lot of more information, right? So, but sometimes you don't know what to do with that information. They have more experience. So you this initial processing you can do, and you sit together with your ops guys, and then the rest of the information you will start looking. Okay, so how is this good for? What is this good for, right? And then you start developing filter extensions together and applying to new dashboards together, and do that in an iterative process. And in order to do that, you also need to have a DevOps kind of a strategy. So as you start having dashboards into staging and that go into production, you know that you're going to have more later, right? So you need a way to automate this transition from staging to production as well. And there are 2 things you can do when you do that. So you, suppose you find a situation where you need to create more filters and a new dashboard, right? Then your production, it cannot go down, right? So you're serving thousands of customers in the cloud with that. So what do we do? There are 2 ways to do this. First is you want to apply these new filters and new dashboards from a point in time, or you want to you want to create like a new staging server that will be promoted to production separately, right? And that's why there are basically two modes to do this promotion here. One is what I call reset, and this line here. So one is what I call reset, and the other is what I call extend. And the difference is very simple. So if reset, you basically are dumping out the data you had in the dashboard and the Elastic, and you're reloading the data from scratch. So you're reloading the logs directly from FileBit to Logstash to Elastic again. So you apply your you just want to do that when you want to apply these new dashboards into data that is already passed, right? It's already historical data. For example, you saw a problem that, okay, oh, wouldn't be nice if I had this visualization this way when something like this happens, right? But it is something rare. It's not something that happens every time. So that's one situation where you might want to do a reset and reload all the data again, right? And then the extend is just apply the new filters and new dashboards, and don't dump any data, and just the new data that's coming in that will be applied to these new filters and new dashboards, right? Okay, so actually here there's a little better explanation, but we can skip that. Okay, so now some of the initial sit-downs that I had with our ops team, right? So actually this was before that. So this is the preamble data that I mentioned to you guys. So up top there's an example of a Cinder log entry, right? So you can see that they always have the timestamp, a process ID, a log level, and a module name. And then some of the log entries are API related. So it's an API call, right? In this case, you have this between braces, you have a bunch of UUIDs. So you have a request ID, and other UIDs can be a user ID or project ID. So things that can give you a little bit of traceability, although nothing related to OpenTelemetry and things that were talked in the previous talk, right? This is nothing to do with that. It's just information in the log there that you can search for. For example, request ID, you can search out that have the same request ID, and you can see all these log entries, they go together, right? But you still have to arrange them, and you have to understand how they fit together. So you still have to do your own traceability here, right? But anyway, so this is just a Logstash filter that shows how to format that properly into regular expressions and load these things into field names, right? I used to something very simple. I used to call the field names log.something, right? So log PID, log module, and log API data is also applied to a different filter in here. Let's see how we were on time.
To be honest, we just have 2 minutes or something left. So
yeah, if you guys can bear just 1 more minute, just want to show just very quickly a couple or more examples. So this is something that you can do with that preamble data, right? So you have high-level views of your information. Then you can use that as a starting point to deep dive. So you'll see, for example, that a lot of HTTP errors are happening. So you can click on this and deep dive and kind of do more troubleshooting. So they didn't have this before. So that already helps them a lot. But there are some other things that they said, oh, we always want to do situation X or Y, and for example, in one situation that they always want to do, but they don't have a way to, they didn't have a way to do that before, was to make sure that the API, the service level for their cloud customers was according to particular parameters, right? So they didn't have a visualization for that, and the logs, they have that information. So we sat together and we started, okay, so let's plot this over time. And this gives a very simple idea if there's spikes here. Sometimes you spend several seconds in order to answer a call on, like you're creating a VM and spend several seconds to do that. And then you can deep dive and see what's causing the problem, right? It's a very simple view that they didn't have before. Okay. And another one that is something that they were lacking as well. So how to do some kind of planning on, this is an example for storage, right? But you could do the same thing for processing resources or memory resources. So you can, some of these APIs, they have total capacity, allocated capacity, and free capacity. So you can plot that over time and see if as you're creating more VMs, this thing goes up and the available capacity goes down, right? So you can do some look ahead, make sure that you add new nodes that have more storage and that you don't run out of storage for your cloud customers anytime soon, right?
Marcelo?
Yeah, that's all that I had.
Okay. Sorry to make the break here. Otherwise, we are completely over time. So please, ladies and gentlemen, applause for Marcelo Perazolo.